In the previous video, we have started to talk about MATLAB structures, right? We had talked about how to create the MATLAB structures in different ways. We looked at how to actually create nested structures. You have one structure as the value of a certain field of a larger structure, another structure or something. And we looked at how to create a structure arrays. It's an array, and every element inside of the array is a structure, right? Is a structure. So we sort of stopped our script here, right? But now let's keep working on it. Let's keep working on it. So one of the things that people may be curious about is about the unassigned fields, right? So for matrices or vectors, right, if you have unassigned fields, then the default value is 0. MATLAB actually fills zeros into those unassigned field, uh, unassigned elements, right? So suppose I do. Let me just go to the. So suppose I create a matrix. Let's say A 2 equals to 1, right? And then for all the rest of the elements that I haven't assigned a value for, MATLAB is going to automatically insert 0 into it, right? And then for cell arrays, the default value is an empty square bracket, right? It's an empty square bracket. And then what about unassigned values for structures, right? Well, unassigned fields for structures, for structure arrays, for example, right? So let me clear all, and then suppose we create at the beginning. Suppose we create a structure first. It has a field of A that has a value of 1. S dot B has a value of 2, right? But later on, suppose we want to sort of expand our scalar structure into a structure array. For example, we create s2.a equals to say 3. Then what's going to be s, right? What's going to be s? So if we just execute these 3 lines, we're going to get something that's a 1-by-1 struct s, right? It's got 2 fields A and B, right? So now suppose let's run this line, right? So what's going to be s? As soon as we finish running this line, we're going to see the dimension is 1/2 structure, right? So now we have a 1/2 struct, and it's got 2 elements, two fields, right? So if I do s dot a, it's 1 and 3. So s1 has a value of 1, right? And then s2 has a value of 3 for the field a, right? But if I look at the s dot b, what's going to be the value, right? So you can imagine s1 is going to have a b field which has a value of 2, right? But what about s2 dot b, right? What about s2 dot b? So if I do s dot b, so s dot b for s1 dot b it's 2, right? But s2 dot b it's an empty square bracket, which means nothing, right? s2 dot b, it's an empty square bracket. There's nothing in it, right? It's empty. There's nothing, right? So this behavior is kind of similar to the cell array, right? So MATLAB is not going to assume some kind of arbitrary data type or data value. It's just going to give you this empty square bracket, which means nothing, right? But what about so this is actually creating a struct or structure array by doing direct assignments to the field name, right? So suppose you want to use the struct. Suppose you want to use the struct function. Suppose you want to use the struct function. So s equals to struct, right? So the field name is a, right? And then I'm gonna have 3 elements in the struct array, 1, 2, 3. Right? The field values are gonna be 1, 2, and 3. And then the field name b is, suppose I'll give like 2 values, 4 and 5. Then what's gonna happen, right? What's gonna happen? So if you look at the, is it consistent, right? So what we are trying to actually create is a structure array that's called s, But how many elements are inside of this structure array? We can't tell, right? If we just look at the A field, we've got like 3 values. So it looks like S is going to have 3 elements, and each element is going to have an A field, right? This A field. Uh, but if we look at the B field, we have only 2 values inside of the cell array, inside of this cell array, right? Which means that S is a struct array with 2 elements, and each one of them has a B field, right? So how Matlab is going to resolve it, right? So let's just run it and find out how Matlab is going to treat it. So it's going to report an error message, right? Array dimension of input 4 must match those of input 2 or be scalar, right? So if it's a scalar, so if it's just a scalar, then every field, every element, the B field for every element inside the structure array is going to have a value of 4, right? So let's run it. Right, so this time it works. It's going to have a 1 by 3 struct, right? So S is going to have 3 elements. Every element is going to have a field, and the value is going to be 1, 2, 3. And then every element is going to have a B field, and the value is going to all be 4, right? All of the values are going to be 4. So S dot A is going to be 1, 2, 3, right? But S dot B is going to be all 4s, right? 3 4s, right? So that's how you can actually do that, right? So if you are using the struct function, it's not going to allow these kind of unassigned fields, right? So if you are using a cell array as the to group together all the values, then you have to make sure that the number of elements among those in those cell arrays are identical. Otherwise, Matlab is going to report an error message. Otherwise, or you can just use a scalar. So in that case, Matlab is going to use the same scalar for all the different elements, right? For the same field, for the B field in all the different elements of the S structure array, right? That's unassigned fields, right? Unassigned fields. You have to be careful about the behavior of Matlab, right? If you are doing this thing, the unassigned field is going to have empty square brackets. If you are doing this struct thing, calling the struct function, you have to make sure that the syntax is correct, right? And then the next thing that we're going to look at is the pre-allocation. In cell array, when we talked about cell array, we also talked about the pre-allocation, right? Because sometimes we're going to have to create a really big cell arrays to host a very large table, for example, right? The same is true about the structs. Sometimes we have to create a really big struct, right? Again, let's clear all. Suppose we just want to create an empty struct. All right. So how do we actually create an empty structure array, for example? So let's call it S 1020 is going to equal to struct A empty, B empty, and then C empty. Right. So what does it mean? What does it mean? So if you look at the left-hand side, we are actually trying to access or index into something that the container S, right? And the index we give it is 1020. We're accessing the 10th row, 20th column of S, right? And then the right-hand side that we're actually creating is a struct with 3 fields, A, B, and C, and each of the field is initialized to this nothing, to this empty square bracket, right? So what does it mean? It means that we're assigning this particular struct to the 10th row, 20th column element of S, right? So by doing that, Matlab is going to automatically create a structure array with 10 rows, 20 columns, right? And every element inside of this structure array is going to have 3 fields, right? The A, B, and C, these 3 fields. And the value for those fields are all initialized to empty brackets, right? So hold down the control key and press enter. So you're gonna see S is a 10 by 20 struct, right? And for now, it's not gonna really tell us the content because so it's just gonna tell us the name of the fields. 10 by 20 struct array with fields A, B, and C, right? So that's one of the ways for pre-allocating or initializing a struct array, right? And another way of doing the same thing is like that. So um, what I'm gonna do is that I'm gonna do s1020 dot a equals to empty square bracket. s1020 dot b equals to empty square bracket. And then s1020 dot c equals to square bracket empty. So that's gonna give us exactly the same effect. So s is still 10 by 20. And then if we look at the, it's giving you exactly the same effect, right? Right. So that's basically a different way of doing the same thing, right? If you have actually so this is actually just for creating empty structures, right? So if you have actually values or some kind of initial values for different fields of a structure array, you can create something that's called a repeating structs, right? So suppose let's still clear all. So s1 to 10 and then 1 to 20, right? It's gonna equal to um, struct A, but all the A fields for all the different elements are going to have a value of 20. And then the B fields are going to have a value of 30, and then the C fields are going to have a value of 40. Right. So now if we actually run this piece of code, hold down Control key and press enter, and then S is still going to be 10 by 20, right? It's still a 10 by 20 struct array, but what's going to be the field values, right? What's going to be the field values? The field values are going to be, so s dot a is all going to be 20. That's like how many 10 by 20 20s, right? And then s dot b is all going to be 30, and then s dot c is all going to be 40, right? So now every field is going to have a non-empty value for all the elements inside of the struct array, right? And another way of doing the same thing, if you have used the rep-mat function before to duplicate to create a repeating matrix of vectors, it's actually the same function. So S is gonna equal to called rep mat, right? So if you haven't used the rep mat before, you can just look at its manual page, help rep mat, right? So replicate and tile an array, right? So A is some kind of array. You are repeating A by m times on the row direction and n times on the column direction, and then that's gonna be your output B. You're tiling up A m times and n times, and then the resulting matrix, the resulting bigger matrix, is a B, right? And you can use the repmat to actually replicate structures, right, and create a structure array. So this time we're gonna the thing that we want to duplicate or we want to tile is a struct, right? And then it's got 3 different fields: A, B, and then C, right? That's the struct array. That's a struct array. And then we're gonna repeat it. We're gonna repeat it by how many times, right? We're gonna repeat it by like 10 times on the row direction and 20 times on the column direction, right? And then let's run this piece of code. So S is again 10 by 20, right? And then s dot a is all going to be 20, and then s dot b is all going to be 30, and then s dot c is all going to be 40. Right. So that's how we can actually create a repeating structure, right? A structure array. So for now, the structure arrays, the field names of the structure arrays looks like variable names, right? But can we actually use strings for field names, right? If we can use strings for field names, then there might be some way for us to actually dynamically construct the field names based upon some kind of a programming logic, right? So let's see if we can actually do that. Let's see if we can actually do that, right? Field names. Field names is actually one of the strengths or advantage of using a structure, right? It gives you some meaningful representation. If you are using a field array, then it's just the indices, right? Indices are just the numbers. It doesn't really have a specific meaning attached to it, right? So the programmer has to actually remember what's actually the index for each of the different elements inside of the field array. But for structs, the field name is actually can actually be meaningful, right? So for now, we haven't actually been using these kind of meaningful field names. The field names are just arbitrary, right? A, B, C, or F1, F2, those kind of arbitrary names. It doesn't really have a meaning attached to it. But in practice, you can do that, right? And make your program more readable or something. And one of the things that one of the functions that allows us to actually extract field names of a particular structure is a Matlab function that's called field names, right? It's just called field names. It's a Matlab intrinsic function, right? Get the structure field name or Java.com object properties, right? So here we have a structure S. It's a structure array, right? And then suppose we want to get the field names of that particular structure array. So how are we going to do that, right? So we can just call field names. And then the input is just going to be our structure array, right? And then what's going to be the output, right? What's going to be the output? So it's going to return a cell array of character vectors containing the name of the fields. So basically it's going to return a cell array, right? So let's call it fields. It's going to equal to field names. So if we execute this piece of code, then fields is going to be, you can sort of see it, right? It's a 3x1 cell. So fields is going to be a cell array. And each element inside of this cell array is going to be the name of that particular field as a string, right? So fields, say 2. And then let me look at the class of it. That's a char, right? So this field names function, this internal function allows you to easily extract the field names as a cell array, right? And each element of the cell array is actually a string, right? So that's one of those utility functions or helper functions that can actually be useful sometimes, right? And then let's look at an example of something that's called a dynamic field name. So by saying dynamic, which means that this field name can be actually constructed based upon some programming logic or on the fly, right? Let's clear all. What we are going to do is that we're going to actually construct a structure that's called guess price. So guess price is going to be a struct. It's going to be a struct. And then its field names are going to be dates. Right? But it's dates organized in a specific format. 3 digits for the month, 2 digits for the day, and then 4 digits for the year. So that's gonna be our format. So how do we actually construct this kind of dynamic field name, right? Matlab allows you to use the smooth parentheses. So it's still dot, right? It's still dot. So if it's a static field name, say dot a, then the name of the field is fixed, right? But we don't want to use a fixed field name. We want to construct the field name dynamically based upon the current date and time, right? So Matlab allows you to actually use a parentheses and then put stuff inside of these parentheses. And the stuff that we're going to put into it is date str. We have used the date str before. It's a Matlab intrinsic function that allows us to actually retrieve the current date and time and convert it into some kind of a format. So now is a Matlab intrinsic variable that's going to give us the number of seconds with respect to a certain reference time, 1970, January 1st, 1970 or something, right? And then if we want to do it date str and then reformat it into month, day, year, and then that's going to give us November 28th, 2017, right? So that's exactly what we want. Now, and then the formatting string, month, day, year, right? So the data str now with this kind of format is going to return this kind of string. And then we're going to use this particular string as our um, as our field name, right? And then let's assign some value to it. Say 2.88 something, right? The gas price is like $2.88 per gallon or something. Right? And now, once we have this kind of syntax, we can actually create field names based upon some sort of arithmetic calculations. Gas price dot, right? Date str. But now, the first input is not going to be now anymore. We're going to use now subtract 30, right? And again, is that a good idea? Let's see, date str, now subtract 30. Right, so if you actually subtract 30, then it's going to treat it as 30 days. Right? Do you see how the first input actually works? Now it looks like it's so now subtract 30 is going to give you a time that's 1 month before now, right? And then we are going to reformat it into like this kind of 3-digit month, 3-letter month, 2-digit date, and then 4-digit year. Right. And then we're gonna give it a different value, say 3.6 something, right? So now let's run this particular piece of code, and then we're gonna get a gas price, and then it's gonna have two fields, right? November 28th and October 29th, right? So both fields are actually organized dynamically, created dynamically. And then if we want to access one of them, right, we can actually reconstruct the field name dynamically also. So d equals to the data str now, right? Right. So now if we want to disp gas price d, then that's gonna give us the gas price that's for now, right? Oh, sorry. I'm supposed to just run this piece of code. it's not. Sorry about that. Dot D, right? It's not really an index, right? Um, no, it's not dot D. Oh, sorry, it's a dot. This thing. Uh, so I myself was like confused about the syntax also. So you have to do a dot, right? You have to do a dot, right? But don't forget, this dynamic field name has to be enclosed inside the parentheses, right? So if you actually enclose this dynamic field name with a parenthesis, Matlab is going to resolve it. It's going to evaluate the stuff that's inside of this parenthesis and then use the result as the field name, right? So this is different from gas price dot D. It's different, right? This thing is just going to use the static name D, right? But gas price doesn't really have a static name that's called D, right? It only has like these two different fields, right? It doesn't have gas price dot D. It doesn't have a field name that's called D. It doesn't have it, right? So you have to evaluate it. So how do you actually make sure Matlab evaluates D? How do you actually make sure that Matlab actually resolves the value of D, right? You use a parenthesis to actually enforce the evaluation. So now it's gonna evaluate to November 28, 2017, and then Matlab is gonna use November 28, 2017 as the field name to actually index into gas price to get the gas price. So now if I change D to date str, now subtract 30, and then month, day, year, and then disp gas price dot D, right? Then it's gonna print 3.6, right? Right, 3.6. So this kind of a parenthesis is actually quite useful. It's actually quite useful, right? Let's look at another example, right? So this example is for medical records. We're gonna use patient's name as the field name, right? So say 49, 58, 98.3, 103, 72, and then records dot mark equals to 25, 60, 98.6, then 105, and then 75, and then records dot Susan equals to 32, 71, 99.1, 0, and 78. Right. So now let's use name equals to input. Patient name. We're gonna ask the user to enter the patient's name as a string, right? So input is gonna take a prompt, and then the type of the input, we're gonna take it as a string, right? And then we're gonna do a disp medical records for name is and then disp records. So how do we actually use this particular name string to retrieve the correct records, to retrieve the correct field, right? Dot is necessary. We have to use the dot, right? But if we actually do name, then it's not going to work, right? Because the records doesn't really have a static field name that's called a name, right? You only see like 3 fields: Kelly, Mark, and Susan. It doesn't have dot name inside of the records structure, right? But name is actually the container name for storing the patient's name, right? So at this point, we can actually force the evaluation, force Matlab to evaluate it by including the variable name, the string variable name inside of the smooth parentheses. we force Matlab to actually evaluate this variable name, and then it's going to be evaluated to whatever string that we have typed in, right? And then now let's run this code. So patient name, let's give it like a Mark, for example, right? This is unexpected. So I think I made a typo here. It's not records, it's records. So that's why it was not able to actually actually execute, right? So let me just rerun this section of the code. Patient name Mark, and then medical records for Mark is going to be this sequence of numbers, right? And then let me execute again. Let's give it some Susan, right? And then let's try something that doesn't exist in it. Let's say Adam, right? So Adam is not really a field for the records structure, right? So reference to non-existent field name Adam, right? So that's how you can actually use dynamic field names, right? Don't forget the parentheses, right? To ask Matlab to actually do the evaluation. Um, so now let's look at how we can actually concatenate structure uh, structure arrays. We're going to concatenate structures into a structure array. How we can actually do concatenation, right? Concatenation. So let's first create a three structure first. S1, capital S1 is going to equal to struct. We're going to use the struct function, right? So it's going to have a field name that's called F1, and then the value is going to be ID underscore 1, and then the field name F2 is going to have a vector that goes from like 2 to 3 to 14, and then a field name F3 that's going to be just a random matrix 3 by 3. Right, that's S1. S2 is going to be more or less the same thing. Let's just copy and paste it. And then ID, let's give it like 3. F2 it goes from like -2 to 3 to 10. And then F3 is going to be rand 3 2, 3 rows 2 columns, right? And then S3 is going to equal to something else. Maybe it's a good idea to repaste it. ID 134, right? F2 minus 3 to 2 to 5. F3 rand 1 row, 1 column. Right, that's gonna give us S1, S2, and S3. These three structs, right? And then we're gonna construct T1. T1 is gonna be a concatenation of the three structs S1, S2, and S3. Right. Let's hold down the control key and the T. So T1 is going to be a 1 by 3 struct. S1, S2, and S3 are both 1 by 1, right? But T1 is going to be 1 by 3. So if I do T1, it's going to tell me that it's a 1 by 3 struct with these three fields, right? So now let's try to do something that's kind of really complicated, right? Suppose we want to let me index into T1. and I'll write the syntax, and then you can try to figure out what might be the output, right? So suppose I want to do a disp t1 1. So what does it mean? t1 1 means I want to retrieve s1, right? s1, and then f3, which means dot f3, which means what? I want to retrieve the field with the name f3 of s1. That's a random matrix 3 by 3, right? And then 1 by 3, one row, third column, right? So that's 0.7566. It's 0.7655, right? So if I look at s1 dot f3, the first row, third column, 0.7655, right? That's what this index actually means, right? Now let's try to sort of create another structure that's called T2. Let's call it T2, and then T2 dot. We're gonna construct a static field name that's called G, capital G, and then the value for this particular field is gonna be T1, right? This particular structure array, right? And then T2 2 dot G is also gonna be T1, right? So T2 is not going to be a scalar structure anymore. It's going to be a structure array with at least 2 elements. Right? The first element, its G field is going to equal to T1. And then for the second element, its G field is also going to have a value of T1. Right? And then let's look at what's going to be the display. So let's look at the syntax first. T22. T22 means what? T22 means I'm retrieving the second element of the T2 structure array, right? Right. And then let's get G, the field G, right? Let's get the field G. The field G is what? The field G is T1. It's the same as T1. T1 is also a structure array with 3 elements, right? Let's get the second element. So the second element is going to give us S2 basically, right? S2 is going to have a field that's called F3. Let's do it dot F3. So retrieve the F3 field, right? And then this particular field is going to have it's going to be a matrix with random numbers, and it's going to be 3 rows, 2 columns, right? Let's get the first row and then the second column, right? And then hold on. So that's 0.5472, right? Is that true? Is that true? S2 dot F3, first row, second column, 0.5472, 0.5472, right? That's exactly correct, right? So when you see this kind of a really complicated indexing or really complicated access pattern, this kind of really complicated access thing, you have to sort of keep a really clear head to actually resolve it one level at a time, right? But in practice, you will probably never see this kind of a complicated thing, right? You don't want to, you really don't want to sort of do this kind of thing because it's just going to confuse everyone. But if you see this kind of thing, you should be able to actually resolve it from left to right, right? But by looking at one thing at a time, So here you have parentheses, you have dots, right? Sometimes we have to convert structure arrays to cell arrays, and convert cell arrays to structure arrays, and back and forth, doing this kind of a conversion, right? Conversion to and from cell arrays, right? So now let's try to understand how this kind of conversion is going to work. Let me write a new section. Right. And the thing that we're going to do is we're going to create a structure array that's called S, and then we're going to use the struct function. And this structure array is going to have the field name that's called A, right? And then how many elements we're going to have for this structure array? We're going to have 1, 2, 3, 4. We're going to have 4 elements, right? And the first element, the value for the A field for the first element is 1. For the second element, it's the character, capital X, and then the third element is magic. It's a matrix, 5 by 5 matrix, right? And then it's a random 3 by 3 matrix, right? Let's just execute this thing. So S is going to be a 1 by 4 structure, right? And S is going to have a field. S is going to have a field. So S1.a is going to be a 1, right? S2.a is going to be X, and S3.a is going to be this magic 5 by 5 matrix, and S4.a is going to be this 3 by 3 random matrix, right? So if you just do S.a, then it's going to list. Then it's going to list the S.a. If you just do that, then it's going to list the values for the A fields of the 4 different elements inside of the structure array, right? But suppose we want to convert those things into another data structure, right? So before we actually do cell arrays, let's look at what's going to be, how we can actually suppose we just assign this thing to an arbitrary thing, say x equals to s.a. Then what's going to happen, right? Then what's going to happen? Say let's write this line inside of the script. So x equals to s.a. Then what's going to be the value of x, right? So when we did the s.a in the command window, if we just type s.a in the command window, it's going to print out the content for the A field for the 4 elements of S, right? But if we actually assign s.a to x to a container name, to x, then what's going to be the value of x, right? So let's execute it. You're going to see x is going to be a scalar. It's just a 1. See? So it's not going to include the values for the A field of the second, the third, and the fourth elements, right? So it just includes the values for the first element, the values for the A field, the value for the A field in the first element, right? That's not exactly what we wanted. That's not what we wanted, right? So how do we actually get all the values? How do we actually get all the values? The thing that we have to do is to do this thing, x1, x2, x3, x4, and then equals to s.a. If we do that, we are going to store the values of the A field for the 4 different elements inside of S, right? So now if we execute it, so x1 is going to have a value of 1, x2 is going to have a value of x, the string x, right? And then x3 is going to be the 5 by 5 magic matrix, and then x4 is going to be the random matrix, 3 by 3, right? So that's how we can actually retrieve all the values of the same field inside of this structure array, right? So once we have this basic understanding, we can try to convert the structure array, convert a certain field of a structure array into a cell array. We can try to do that now, right? Let's clear x. Let's get rid of the x, right? And then we're going to recreate x. But how we are going to recreate it? How are we going to recreate it? We're going to do this thing, x1 to 4. We're going to do that, right? So if you look at the left-hand side of this particular expression, it's like 4 things concatenated using the square bracket, right? So here I'm actually indexing into something that's called x that doesn't exist yet because we have cleared x, right? But we are doing this kind of content indexing into this X, right? So MATLAB actually knows X is going to be a cell array, right? And it's at least going to have like 4 elements inside of that cell array, right? So because it's content indexing, you see the curly brackets here. So it's gonna MATLAB is gonna create a cell array and then with 4 elements and then unwrap all the cells and retrieve the content and then arrange all those contents, 4 contents actually. It's the content for 4 cells basically. It's gonna concatenate the content for the 4 cells just like this thing, right? And then if we do an s.a on the right hand side, that's gonna assign all the content inside of the A fields into the left hand side, which is a concatenation of 4 different things, right? And these 4 different things are actually the content of the cell array, right? So now let's look at the X. X now is a 1x4 cell. See, X is now 1x4 cell, right? The first element is still the scalar 1. The second element is going to be the character X. The third element is going to be the 5x5 magic double magic, the magic number, and then the last one is a 3x3 random number, right? So we have actually converted the different fields, which has very different data types, into a cell array, right? Maybe the shape of the cell array is not exactly what you wanted, right? So maybe that's you don't want a 1 row 4 column. Suppose you want a 4 row 1 column, that kind of thing, right? How do you actually do that, right? So let's create an x1, right? X1 is going to equal to, we're going to use cell, right? 4 row 1 column. We used the cell function before, right? It allows us to actually create a cell. And then we're going to do x1 equals to s.a, right? So here we are not specifying the starting and ending index now, but MATLAB is going to take the shape of x1, which is 4 row 1 column, right? It's not going to change the shape, right? It's just going to take each element of this particular cell array, unwrap those cells, retrieve the content, and then arrange those content into this square bracket, and then do this assignment, right? And then let's run it. We're going to see x1 now. X1 is going to be 4x1 cell, right? So if you want other shape, say x2 equals to cell 2x2, for example, right? And then you can do x2 again without specifying the starting and ending index, right? Equal to s.a. Now x2 is going to be 2x2 cell, right? And then let's try something that's let's do x3 equals to cell, but this time it's 1 row 3 columns. Then what's going to happen, right? So x3 is going to be 1 row 3 columns. So what's going to be the stuff that's inside of x3, right? 1 x 5x5 double the magic array, the magic matrix, and then it's going to ignore the last thing, which is the 3x3 random matrix, right? So it's going to, so on the left hand side it's just got like 3 elements inside the square bracket, but on the right hand side you have like 4 different things, right? And then if you are assigning these 4 different things to these 3 things in the square bracket, it's going to drop the last one, right? So that's like the default behavior. So this is converting a certain field of a structure array into a cell array, right? So suppose we want to do the opposite thing. So we want to convert cell array into a certain field of a struct array. So how can we actually do that, right? Let's look at the incorrect way first. Suppose we do s1.a. We are trying to create a structure array that's called s1, and then it's gonna have the field a, right? And then let's just do x 1 to 4. We're doing this kind of content indexing now, right? So is it going to work? Right, let's just execute this line. Right. So it looks like it has worked, right? But does the structure actually has what is the result what are we expecting? It's not, right? S1.a has a value of 1, right? S1 is what? S1 is a 1 by 1 struct. That's not what we wanted. We want a 1 by 4 struct, right? And each one of those elements in the struct array has a field a, and then the value being distributed correctly, right? So how do we actually deal with that? How do we actually deal with this particular function, right? So how do we actually solve this problem? So the correct way for doing the opposite conversion is to use the Matlab function that's called a deal. Right? It's just like dealing a stack of play cards, right? Those poker, in those poker player, you have to deal the cards to different players, right? The Matlab deal function does exactly the same thing, right? So you're gonna have a bunch of input to the deal function, right? X, Y, and Z, that kind of thing. And then the deal function is going to take x and then assign it to the first output, take y to assign it to the second output, and then take z to assign it to the third output, and then goes on. If you have more inputs than output, then it's going to go around, right? And then do this kind of thing in a round ribbon fashion, right? Um, so let's use the deal function, right? S1. This time we're going to do 1 to 4 dot a. Right. And then it's going to equal to deal x 1 to 4. Right. So we're doing a content indexing into the cell array x. Right. So it's gonna unwrap all the cells and then put together all the 4 different things, and then it's gonna deal it to S1. So now if we look at S1, it's a 1 by 4 struct, right? And then let's look at what's actually inside of S1. S1 is gonna have a field that's called A, and then S1.A is gonna have all the correct things inside of them, right? And that's converting a cell array to a struct array, right? There are more complicated conversions. But it may not be necessary to actually discuss all of them, right? When you actually have a very specific problem, you can think of a different ways of dealing with this kind of conversion, right? But in practice, it's never more complicated than this kind of example, right? So let's stop this video here.